Before we move on to another example, I just wanted to look at the result we got from that last question where we were finding the inverse matrix of 1, 2, 3, 4, and just show you that we can in fact verify that this is the matrix inverse by doing a matrix multiplication. Okay, so if I take my two matrices, in this case A is 1, 2, 3, 4, and A inverse is minus 2, 1, 3, 2, 3 on 2, minus 1 half. Okay, we're going to do that matrix multiplication. We should be able to see pretty quickly whether we've gotten the right answer. So matrix multiplication, we're going to match up our rows and columns. We're going to go 1 times minus 2 is minus 2. 2 times 3 on 2 is positive 3. 1 times 1 is going to be 1. 2 times negative a half is negative 1. Third element is first row, first column. 3 times negative 2 is negative 6. 4 times 3 on 2 is going to be, 4 3s are 12, 12 on 2. And finally the bottom right element, second row, second column. 3 times 1 is 3. 4 times negative a half is negative 2. Alright, let's tidy this thing up. Top left corner, minus 2 plus 3 is just 1. Top right, 1 minus 1 is 0. Bottom left, minus 6 plus 12 on 2. Now 12 on 2 is the same as 6. So this is really minus 6 plus 6. Minus 6 plus 6 is 0. Finally, the bottom right corner, 3 take away 2 is just going to be 1. And we get this matrix here. Now this matrix here has a special name. If you remember, we call this the identity matrix. And we represent it with I. It's the matrix with 1s on its diagonal, main diagonal, and 0s everywhere else. And we know that we've calculated the correct matrix inverse if when we do this multiplication we get the identity element. And this was because this was the definition of an inverse. Okay, an inverse matrix was defined as the matrix that if I take A and multiply it by its inverse, I have to get the identity matrix. Okay, the same as if I take a number like 2 and multiply it by a half, its inverse, I get 1. Or if I take 2/5 and multiply it by 5 on 2, I get 1. Okay? Just like numbers have multiplicative inverses that give us 1 when we multiply them together, so too matrices have inverse matrices that when we multiply them together we get the identity element for matrix multiplication, the identity matrix.